My dear student, today I will be starting new modules, and the modules is basically projectile motion. And projectile given angular projection. In previous period, I explained the projectile when a body is thrown in horizontal direction, and now today projectile given angular projection. So when a body is thrown in upward direction with initial velocity with u with respect to the earth, then its velocity u is max angle theta with horizontal axis. So V has two components. In horizontal direction u cos theta, and in vertical direction u sin theta. All of you know this is the horizontal range. This is the initial point of the object, and when we throw in upward direction it reaches at a point P up sometime P. So distance covered by the body, this distance covered by the body, basically x is equal to distance is equal to velocity into time, and the velocity in horizontal direction of the component of u is equal to u cos theta. So u cos theta into t, and then t is equal to x by u cos theta. So this is my first equation. Now for vertical direction, this is the vertical direction where u is equal to u sin theta, and a is the acceleration due to gravity, so it is denoted by g, but the direction of g is negative, so it is indicated a is equal to minus g. We know the formula S is equal to ut plus half at square. In vertical direction, the distance is denoted by y-axis y and ut. So the component of u is equal to u sin theta. So u sin theta into the value of t from equation first, x by cos theta, minus, because g is negative direction, so minus half g x square by u square cos square theta. And after solving, this is equal to u sin theta x upon cos theta. So this is equal to x. This is also u cos theta. So he will be cancelled. So x into tan theta minus half g x square upon u square cos square theta, and y is equal to px minus qx, where p basically indicated as tan theta, this is the constant quantity, x square and q is indicated by half u square cos square theta. So finally we get y is equal to px minus qx. So where p and q are the constant, y is the quadratic function of x, and hence the trajectory of the particle is parabola, just like in the previous period. This equation is basically parabolic equation. So the path of the object is parabolic. This motion is basically known as parabolic motion, and the object is known as projectile. So now we find the time of the maximum height. So when a body thrown in upward direction, so what is the basically time of the maximum height? In maximum height, what is the basically time? So for this, when we throw in upward direction a object the velocity of object at the maximum height is equal to 0. We know a equation v is equal to u plus ad. So in y direction, vy is equal to uy plus ay into t. We know the velocity in y direction at the maximum height, this is equal to 0, and this is equal to uy. Uy is the basically uy is equal to u sin theta minus g into t, and our gt is equal to u sin theta, and t is equal to u sin theta upon g, and this value is basically known as time of. So this time of the maximum height. So now we find the time of flight. So when a body is thrown from the surface of the earth, first it goes the maximum height, and then again it reaches the surface of the earth. Then the time taken from the maximum height and the surface of the earth is basically known as time of flight. So this time is multiplied by 2 because time taken at the maximum height is equal to u sin theta upon g. Same time taken from this point to the surface of the earth. So t is equal to 2u sin theta upon g. So now next, this is the maximum height. What is the maximum height of the object when thrown in vertical direction next and at angle theta with respect to the earth? So again you use at the maximum height its velocity is equal to 0. Now we know the v square minus u square is equal to 2as. All of you know this formula. Here the velocity at the maximum height is 0 minus u square sin square theta. This is the component of u in vertical direction. So u sin theta, so u square sin square theta, this is equal to 2g minus the acceleration due to gravity is negative direction. So this is denoted by minus 2g. G is just a g, and h is the distance. This is the maximum height. And after solving this equation, h max is equal to u square sin square theta by 2g, and this formula is basically for maximum height of the projectile. Now at the last, horizontal range. Horizontal range means from initial point to final. This is a distance. So all of you know distance is equal to velocity into time. So horizontal range is equal to velocity. In which velocity? Horizontal velocity into time of flight from maximum height to the final position. So r is equal to, this is the horizontal velocity u cos theta, and this terms indicated the time of flight. So you multiply time of flight into horizontal range, and then you get u square by g into 2 sin theta into cos theta. We know with the help of trigonometrical function, 2 sin theta into cos theta is equal to sin 2 theta. Then we find the final relation r is equal to u square sin 2 theta upon g, and this is the value of the horizontal range. So in this projectile, we find first of all the motion of a projectile is basically parabola, and my next topic basically time of maximum height. What is the time taken by the projectile at the maximum height? My third part is the maximum height. So h max is equal to u square sin square upon 2g. Then we find the horizontal range of the object, and we get r is equal to u square sin square theta upon g.